You too.
Okay, relative extrema. So we're going to define what relative extrema is at the top. So relative extrema, the relative maximum, which I'm just going to call max, is a y value peak that is not the absolute highest point. I don't know how I'm going to fit all this in here, but we'll do it. So a relative max is a y value peak that is not the absolute highest point. So you can think of a relative maximum as being like, okay, what's the highest mountain that we have close to here? Uncompahgre. So Uncompahgre would be a relative maximum height because for this area it's the highest peak.
But it's not as tall as Everest.
But it's not as tall as Everest. So it's not an absolute maximum, but it's a relative maximum because it's the highest peak in that area. Okay, and so we need to do a relative minimum too. So I'm just going to kind of write that over here. So if we have a relative minimum, or I'll just call it min, that is the y value valley. We'll call it a valley. I should put peak and valley in quotes. So it's a y minimum valley that is not the absolute lowest value. So the key words here that'll help you remember it is we're looking for peaks and valleys. The top of the hill, the bottom of the valley. Okay? So if we're going through this graph, oh, and it's all y values, which is different than what we did with increasing, decreasing. That was x values. So right here I see a peak. This would be
Widow's peak?
a relative max. So we're going to kind of look over here to the y-axis. How high is that? 2. So a relative max right there is 2. So over here I'm going to write relative max of 2, and it happens at x equals 1 to negative 3. So the 2 is the actual max. I'm going to put a circle on that. But then we can also describe where it happens at. If we're looking at a real-life scenario, and we did a little bit of this with graphing calculators last year. You probably don't remember. We did this a little bit where we were finding like when something would get to like a highest profit or a minimum cost, stuff like that. Sometimes you want to know when it happens. Okay, so that was the relative max. Now if we just kind of go along, we come down here. There's a valley. So this would be a relative minimum value. So let's see how low it goes. 1, 2, 3. So that's at negative 3. So a relative minimum, so I'm going to put that under min, at negative 3 happens when x is negative 1. Good. So that's my relative min down there. This is not the lowest point because over here I have this arrow showing it actually goes to negative infinity. It can go as low as you want. But in this particular part of the graph, it is the lowest point. Okay? So then we come over here, just traveling along. We've got another peak right here. So this would be another relative max. And so that comes up to 1. I'm going to put that under the maxes. So my relative max is 1. And it happens at x equals 1, 2. So we'll just keep track of that over here. So it's a max. Maximum value of 1. It happens when x is 2. And then over here we have another relative minimum, another little valley, and it goes down to negative 1. Good. And it happens when x is 1, 2, 3, 4. Okay, so another name for this that I have seen used in some textbooks that we'll just write down at the bottom, sometimes they will call these local maxes and local mins instead of relative. It just depends on what textbook or what professor you happen to go to. So I'm thinking about college algebra right now, or calculus, depending on what you end up taking. And so it just depends on what textbook you're using and what professor you have. They might call it a local max or local min, or relative max, relative min. It means the same thing. Okay? I only know because I've used a zillion different textbooks that not everybody calls it the same thing. All right, so the next thing that we're going to look at is the absolute extrema. So I'm going to go down to that. I'm going to zoom in a little bit. Okay, so absolute extrema. So for an absolute maximum, which I'm just going to call a max, it is the actual highest point. So not the highest peak in Hinsdale County, but the highest peak in the world, the absolute, which is Everest, or is there one? There's one higher than Everest, isn't there?
Underwater volcano thing.
Oh, underwater volcno. So, but the absolute highest maximum point wouldn't be here. It would be whatever the highest mountain in the world is. So we have to kind of think about that using that analogy. And then if we have an absolute minimum, that's the actual lowest point.
Mariana's Trench.
Huh?
Mariana's Trench.
There you go. Now I will point out that anytime you have arrows going up or down, sometimes you don't have an actual point. You might have some infinities. Good job. I like that word infinity coming up. Okay, so let's start with this one. Do we have an absolute maximum? I have a relative max here and a relative max here, but I have arrows here and here. So this does not have an absolute maximum point. I can't write one down. I mean, you could say it's infinity, but what does that really tell us? It just goes forever. We do have an absolute minimum right there, because we do not have arrows on the bottom of my graph. So I'm going to go through all my minimums and find the lowest of the low, which would be this point right here. And so we're going to see how low it goes. So that is lining up with the y-axis at -2. So it's an absolute minimum, we're going to put min in that little blank, of -2 that happens at x equals -3. So we had an absolute min, but there is no absolute max because it would just go up to infinity. So they don't call that a maximum or a minimum because it's not actually a stopping number. Does that make sense? Okay. You can have little functions. If you've got piecewise functions where everything is a segment, you can have an absolute max and min in the same function, but a lot of our functions that we're going to look at are going to have arrows somewhere. All right, so let's take a look at the other one. It's this one that kind of looks like an M. So if we're looking at the tops, we definitely have a couple of maxes up here. This one looks higher, so we're going to kind of line that up with the y-axis. It goes up to 3, and that would be an absolute max. So it would be an absolute max of 3 at x equals 3. So just lots of 3's. And then if we look at the minimums, I have a relative minimum here, or a local minimum if you want to call it that. But then if I go to the ends, these are going to go down forever and ever and ever. So there is no absolute minimum because it would just be negative infinity. I just realized over here my absolute does not have a T, so I'm going to fix that really quick.
Did you steal this?
Yeah, I definitely stole this.
Because
Well, I didn't steal it. Teachers post these things for free for other teachers to use with no instructions. This is supposed to make a little booklet that you glue in, and I'm not smart enough to make the booklet, so we're just going through it like it's slides.
on the next one I said was, can I use a graphing calculator to find extrema when given a equation?
Yeah. So I didn't type that. Yes. Okay, so let's keep going. So on the next page, on page 124, extrema. Okay. So we're going to look at how to use a graphing calculator to find extrema when given an equation. Now this one has an absolute value in it, which is a little bit exciting to type into the calculator. So I'll show you that here in just a second. So our steps, step 1 is to enter it into the y equals menu, which you guys know. So we'll write down the steps and then we'll do the steps. And then step 2 is to hit graph. If you have a weird window, you can do zoom and then number 6. And that gets you usually to a nice window. Sometimes you have to adjust, but that usually works. Oh, I'll make a line on my Z. Sorry, it does look like a 2.
It kind of looks like Ian's eye, actually.
Okay, so let's take a look at number 3. So number 3, you hit the second. All right, here we go. Okay, so my video cut out a little bit. If you want to go ahead and put steps 3 and steps 4 on your paper, you can. We're actually not going to use step 3 for this example, but it's something that we talked about last year that you could use the calculator to help you find the minimums and maximums a little bit. So the 2 main steps are putting it into y equals and graphing and using the zoom 6 if you need to change your window. Now, this particular example has absolute value. So if you want to do absolute value on the graphing calculators, you push the math button and then the right arrow so that you're in the number menu, and then you will select option number 1. So I will go through that process with you on my calculator. Okay, so I have already pushed my y equals key right here to get into this menu, and we're trying to put in the absolute value of x squared minus 4. So to get the absolute value, you go down to the math button and push that, and then we're going to use the right arrow key over to number, and where it says ABS is absolute value. So you will select number 1. And then you just put whatever's in the absolute value bars inside parentheses. So for this example, it was x squared minus 4. And then I just close the absolute value bars to show that that's where the end of the absolute value bars would go. So you close the parentheses to show where the absolute value bar would be. And then if your calculator is set up, you can just hit the graph key and see the graph. If that doesn't work, then you'd want to do the zoom and adjust the window. So this is what our graph looks like. For the purpose of our notes, what we want to do is take this graph and sketch it really quick on our papers. And since my video cut out earlier, I've already got that on my paper. So let me adjust my screen a little bit and I'll show you this. I noticed that it was hitting the x-axis at -2 and 2, hits the y-axis at 4, so I just drew that graph in really quick. And you could pause this video to get that graph on here. So if we're going through and looking at maxima and minima, I noticed that I do have a peak up here that would be a relative max, and it's up here at 4. So we would say that that's a relative max at 4, and that's when x is 0. I do not have an absolute maximum because I have these arrows showing that the graph would just go up and up forever. So it's just a relative maximum right there. Now I do have 2 absolute minimums right here, the bottoms of my valley. The graph does not go any lower than this anywhere. So those are sitting on the x-axis, so that would be at 0. So I would say that I have an absolute min at 0 when x is -2, and another one at 0 when x is 2. They sort of tied for the bottom of the graph. Okay, so you can pause that to get anything you need. Hit rewind. My video recorder stopped recording and I didn't realize, so I already had that written in. Let's go on to the very last piece. What if the graph has a horizontal asymptote? So we've talked about vertical asymptotes a little bit. We're looking on this at the high and low points, and so we're going to look at horizontal asymptotes. So there is a horizontal asymptote right here, which lines up with 2 on the y-axis. These lines do not go lower than 2. And there's also a little something going on down here at -2, where the top of this little UE is. It sort of hits right there, not actually an actual asymptote, but sort of a little something going on. Okay, so if we're talking about maximums and minimums, the first thing I'm going to look for is peaks and valleys. This is a peak. This would be a relative max right there. And so I'm just going to write that over here next to extrema. So I'm going to say that I have a relative max of -2, and that's happening at x equals, let's see, it's kind of right between 2 and 3. So we'll say x equals 2.5. Sorry, that's not showing up. Let me try again. At x equals 2.5. There we go. So that is a relative max. We don't have an absolute max because these two parts of the graphs at the top go up forever and ever, so that would be infinity. If we're looking at minima, we're looking for valleys, and I really don't have any valleys like that. This does not count as a minimum. It doesn't really touch at 2 ever. It just kind of keeps going there. If we look at the bottom of our graph, this just goes on forever and ever, so there's no absolute minimum, there's no relative minimum. Really, we can just talk about the relative max at -2, and that's all we would have for this particular graph. Okay, I'm done.